Well, hello, pre-calculus students and seekers of general truths. Let us firm up and then explain the general form of the binomial theorem here. And I'm going to do one more example here, and I'm going to do it in a different way, just so that it helps to reinforce these concepts. Okay, so notice here what we've done in the previous examples is we talked about how to count the ways that these factors can come together, and we've always talked about it from the perspective of the A's. So if there are 3 A's and 1 B, it's 4 choose 3. If there's 2 A's and 2 B's, then it's 4 choose 2, right? If we have 1 A, then it's 4 choose 1, okay? And what I would like to do with this last example here is to count it from the perspective of the B's, okay? Just to show you that it doesn't really matter, and we will arrive at the same solution. Okay? So we know that if we were to do a plus b to the 5th power, every term is going to have 5 factors, right? So it's kind of like we're going to fill these in. And one of the possible factors, one of the possible terms is that we're going to have 5 A's, okay? Or another way to say it is that we're going to have 5 A's and 0 B's, okay? So that's going to be 5, it's going to be A to the 5th and B to the 0th. Okay? And again, I'm saying that I'm going to count this in the perspective of B. So we can say that this is 4 choose 0. Okay? 4 choose 0. So there are 4 choose 0, which is just 1. Okay, if you have to choose 0 things, there's only one way that you could do it. So this 0 here corresponds to that 0 there, right? So this is like saying if I'm just gonna fill this up with A's, then there are only one. There's only one way that I could do that, to fill them up with A's and have 0 B's at all. Okay, the second term, the type of term that I could have is if I have 4 A's and 1 B. So A to the 4th, B to the 1st. Okay, so that could look like this. It could be A and a B, but I could also rearrange these letters however I want. And there are, oh, excuse me, I messed this up. There are, in this first one, there should be 5 choose 0. Not 4 choose 0. There's 5 choose 0. There's 5 slots, okay? So in the second one, again, there are 5 slots, and one of them has to be a B. So I'm choosing, I can move this B anywhere here and rearrange it. So there are 5 choose 1 different ways for us to do that, okay? And then if I continue here, my next possible term is going to be A to the 3rd, and there's going to be 3 A's and 2 B's, so A to the 3rd and B squared, right? So that's like having another B in here somewhere, and I can rearrange these B's however I want, and there are going to be 5 choose 2 ways of me doing this. Okay. Next term is if I were to have 2 A's and 3 B's. Okay. So let's say I add another B here. And again, I can rearrange these B's however, these letters however I want, and there are going to be 5 choose 3 different ways to do that. So I have 5 slots, and I have to pick 3 of them to contain a B. Okay? So as we continue, you can see that the next term is going to be 1 A and 4 B's. Okay. So now the B's are becoming more dominant. So if I have a B here, and there are effectively 5 slots and 4 different ones that I want to fill with a B. So that's 5 choose 4. And then the very last term is going to be if these were all B's, okay? So these were all B's. So there are 5 slots, and I want to pick 5 of them to contain a B. So this is, and there are going to be 0 A. So A to the 0th power, which is just 1, and then B to the 5th power. Okay. And you can put all of this information into a calculator, and crunch them, and this is what you will get. 5 choose 0 is just 1, so 1/8 to the 5th. And remember, b to any base to a 0 is just 1 as well. And so all I've done here is calculated 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and so on. And this is what it gives me. And you see that the binomial theorem now really is powerful because it is way faster to do this than to manually multiply out a plus b, a plus b, a plus b 5 total times. Okay, so hopefully at this point you can state the binomial theorem by yourself, but we can do a generalized version of this. If you have a plus b to the nth power, a few caveats here. N has to be a positive number. If n is 0, then the whole thing is just equal to 1, and if n is negative, then we have a whole different story altogether. So this idea of counting combinatorics, the binomial theorem as we're learning it right now, we're only applying this if n is some positive number. Okay, so if this is the case, then you can see the logic follows as this: n choose 0 times the first term to the nth, the second letter here to the 0th. Then as we continue to build, and it becomes n choose 1, right? And then we lose a power from the first term. That should be n minus 1. And we gain a power in the second term. So this power up here decreases by 1, and this power here goes from 0, for like the b's, goes from 0 to 1. Okay. And then n choose 2 until the first power loses the first factor loses a power, the second one gains a power, and we continue this on until we get to the very end where you have n choose n, right? And the a goes all the way down to 0, and the b has power raised to the n. Okay. So there you have it, the binomial theorem. It looks pretty gnarly and wild if you just look at the final version, but hopefully this video and the previous one, as we step through this slowly, you get a sense of where it's really coming from. And this is again like an advanced version of counting, right? So we're counting, but in a systematic mathematical way. As always, thank you for watching. Ask for help if you need it, and have a wonderful day.